Hello and welcome. Hello and welcome, wherever you are, wherever you're coming from, and welcome to Kong Builders. For the next 1 hour, you're gonna spend the time with me and my partner in crime, Danny Freese and Viktor Gamov. We're gonna entertain you with some cool new tech that we're building here at Kong. Danny, welcome back to Kong Builders.
Hey, thanks for having me back.
No, it's always pleasure to have you back. And as always, we're doing this as a kind of like a warm up procedure, and we're not that savvy on this kind of like a internet influencing thing. So we're not saying, oh, like let's wait another five more minutes so the more people will join. No, we're going in straight directly. And if you're joining us in any moment of time, I'm just like monitoring my comment section. Whenever you join this, write down where you're coming from and what you're drinking today. That's our thing. So I am
Drinks of
coming to
choice.
you at beautiful New Jersey today, and I'm drinking, as always, I'm drinking Uptime, the best drink for DevOps. Not sponsored, though they can. I just like it. It's zero sugar and pretty cool with the caffeine and stuff like that. So I need a more of this. Danny,
Uptime.
what's your
Haven't heard of
drinking?
that. Drink of choice is Drink of Champions, water in a pint
Yeah,
cup.
oh, nice. Yeah, that's great. That's great. Where are my comments section? Let's see. We supposed to be broadcasting into many platforms. We're probably broadcasting to YouTube. We're broadcasting to LinkedIn. We broadcast to X.
X.
X gonna give it to you. Um, Twitter. Also, it's always will be Twitter in my heart. So, uh, we have like a pretty cool show for you today. We're gonna be talking about very cool new technology. For some people, it's not new. For some people, in the Conk world, it's definitely has been around for a while, and we were talking about this since I guess last year. And I'm happy to talk about this today. We're going to be talking about WebAssembly. We're going to be talking about Conk. But before that, let me do quick announcement. We are today uh, releasing this stream. Not usual time. Our usual time is the last week of month and the last Wednesday of month. But there is a reason for that. Why we're doing this? Because next week I need to put the things to drum rolls. Yes. API Summit.
It's better.
No, seriously, it's gonna be great. It's the number of announcements. I'm not spoiling anything here. If I would hyper pump up people a little bit. Number of announcements that is coming to the summit is just crazy. I've seen some previews. Um, I can tell anything. It's just like you have to be there. So it's free, it's virtual. You can watch this on your own pace. Some of the announcements will be done through the written if you in it's your jazz, but I highly recommend to join some other talks. Danny, are you speaking there? Like, did you do any recordings of your talks?
I'll be there virtually because it's pre-recorded. But I did the fundamentals with API monetization with one of the new senior product managers of Connect. So I hope you guys
Nice.
enjoy it.
So
It goes into the basics, you know.
we were asked this question multiple times about the monetization and all these cool things that you can do on the gateway side of things, like what's the proper way to do this, how the API gateway should solve it, or like should it be like a built-in integration with some paid platform so you can start charging people
Yep.
immediately. So it is really cool.
It is pretty
um
cool. Yeah, it was really interesting.
oh, so we have some people showing up in the comments. Great. So we have Rajesh from North Yorkshire, England. Welcome and drinking coffee. So you should, like, if you come in, Rajesh, you come in from Yorkshire, England. You should drink at least Earl Grey. I'm not saying like English breakfast or whatnot, but welcome. It's great to have you here. Jonathan from Brazil. We have John Williams from India. Welcome. People drinking coffee. We have our friend Kat. How do I step into the? So now you're in the future. So now you're officially in the stream. You're officially in API future. And as always, in order to step into API future, you just need to go to click register.
You just,
Um,
yeah.
Another thing is that we were talking about the last time, and I continue to talk about this. The hackathon, API hackathon. We have very cool prizes for this, and I think it's more important not about prices. It's more about like what you can build, what some cool things that you can build out of it, and AI definitely opens up the possibilities what you can build. So I'm excited. So go sign up, find your team, and send your submissions. Time is running out. You have a almost this week is already Wednesday, so meaning that the week is almost over. um, so yes, you still have some time to hack something around on your weekend. Now, with this out of the way, I also absolutely don't want to tease anything about the next episode that we're gonna do. Many people of you who've seen the previous episodes of us know that we were enjoying doing serverless platforms and deploying Kong on the serverless platforms, configuring Kong in the serverless. We have a control plane that is running on serverless. We have a data plane that runs on serverless. In the next month, we're gonna have some special friends from the platform that we really love, from Koyeb, that we already put through paces in the stream. So we will have Jan from Koyeb to build something with us. So I'm excited about this. All right. So let's see. We have a few more friends here. So we have Kurt from Ghent. How you pronounce this? Ghent from Belgium. And fries. I went to Amsterdam and I didn't have fries. So I also would love to have some fries. Uh, so Mateus from Brazil, our friend Lakash, welcome. Also stepping into API future, living the API future.
Little
Thanks
cash.
for being here. And we have Conchita. I hope I'm not butchering your first name. Welcome from Italy. Wow, but living in the UK, from Italy and living in the UK, fantastic. Oh, we have some cool ideas for the next topics. Maybe integrating with the. This is the Danish like playfield. She knows
That
the
is our
AWS
domain.
inside out. So I think we will be able to do this type of stuff. Cool. Um, Tom, hopefully, if you coming from the Chicago, hopefully we'll see you in person in the KubeCon, because KubeCon coming in Chicago, and we will have some representation there. I will be there. Unfortunately, Danny will not be there, but maybe next time. So cool. So let's jump right in. So Danny, I will be showing your screen in a second.
Let's do it.
What are we going to be talking about today?
Ooh, it's a big topic. WebAssembly and
It is.
Kong from the beginning. From the beginning. I'm going to cover the basics. I'm going to cover the beginning. Um, yeah. Do you want me to get started? Do you want me
Yes, you
in
can
the
get
beginning?
started. You can even zoom in into this to the point and not spoil anything
Yeah.
before we reveal this.
Yeah, we don't want to spoil anything, but it's Wasm and Kong and why are we doing all of this? That's kind of where I start whenever I'm learning something. So I started when Vic said we're doing a episode on WebAssembly. I'm like, well, what is WebAssembly and how do I run this thing? So we're going to start with how do I run a WASM thing and why is WASM cool in the first place? So WASM allows you to basically code in in any of a lot of the popular languages. Go, Rust are two of the common ones, and it lets you compile something into a WASM module. And when you have this WASM module, it's basically bytecode, so it's going to run very quickly. And we can take this bytecode and we can run it inside a WASM runtime, which is equivalent. It's not equivalent to, but it's almost analogous to it's a sandboxed virtual machine, a memory safe sandboxed virtual machine. And there's lots of popular runtimes out there today. You'll hear about Wasmer, you'll hear about Wasm Time, you'll hear about V8. And the whole rigmarole or the all the excitement came from being able to run WASM in the browser with JavaScript, not as a
Mm-hmm.
displacement of JavaScript, but to help support some of the more compute intensive things that JavaScript had to do. So now you could,
It
yeah,
turns out to be a very interesting thing. So the topic of virtual machine is not new, right? So the things about the there was a Smalltalk virtual machine, there was a Java virtual machine after that, and after that, this virtual machine came into the world of the browser somehow. And the interesting enough, uh, some people just simply love writing virtual machines. That's just like story, like unrelated story. So I'll just put the marker. Um, a
that's what I do
story
in my spare time.
on, yeah, story on VMs. Um, in I came from Java, so like I love virtual machines. Like I get to adjust to love virtual machines because it was kind of like a weird, like why I need to compile something in intermediate code and after that let some other thing to run it, versus why I cannot just compile it to native code and run this on the platform. It turns out there are many platforms, and you need to take your code and compile to each and every platform. And it's good when your toolchain will support this. So the virtual machine actually solving this problem. So virtual machine vendor provides you the way to run this anywhere. The cool thing is that people who initially started their careers writing Smalltalk virtual machines, they were acquired and they built a hotspot virtual machine in Sun back in the day. So, and what it does, it introducing what's called like just-in-time compilation. Essentially, it takes the bytecode, and as you run your application and you're putting this through the cycles, this virtual machine analyzes code, finding this called hotspots, meaning that the pieces of the code that will be executed more often, and those things will be compiled in the machine code, speeding up performance. Same people went to Google afterwards. They brought the Dart virtual machine and they contributed a lot of things into VM. So into V8, sorry. V8 is a JavaScript engine. What takes your JavaScript code and actually compiles it just in time in order to execute your JavaScript faster, compiles in machine code. Now, what brings us to WebAssembly? So it takes not only JavaScript, it takes the languages like Go, Rust, some other languages, compile them into the code that will be able to execute by V8, for example, and V8 also WASM machine, and there was some other runtimes that will be able to execute this. The point is, browser was kind of destination, but for us, for people in the API gateway world, browser is not the destination. Browser is just the beginning of the thing. And we're not running stuff in the browser. We're running stuff in the server. Danny, what's the story with the stuff running the gateway? Can we do
Yes.
this?
We can do it. And that's why we're going to ask the question. And that's where the next question came up like, why the fudge? I am at Kong. Why the fudge do I care? And we work with proxies every day. What kind of proxies? Well, there's lots of proxies. We've got Kong as a proxy, Envoy as a proxy, Nginx as a proxy. Mesh can even be is constituted as a proxy, right? It's based on Envoy
Yeah.
as well. So proxy is the language that we're actually interested in, which brings us to proxy-wasm. What is proxy-wasm? The definition that you'll see floating around is it's a proxy-agnostic application binary interface standard that specifies how proxies and WASM modules can interact with each other. So it's basically a specification such that any proxy that implements the specification can interact with a WASM runtime, which is pretty cool. Why does this help us? Or how does it work? Well, I'm going to take that same, I'm going to make this a little smaller. I'm going to take the same code that I wrote in the just my hello world. I'm going to make it into a request transform. I'm going to maybe like change out a header. I'm still going to write it in my favorite language. I prefer Go these days. And I'm going to compile it to the proxy-wasm SDK. It's going to create this WASM module. And I'm going to somehow get this module. It depends on the proxy, but it gets deposited in your runtime. Now your proxy, whatever it may be, because it implements this interface, it understands how to reach out to the runtime, execute this new plugin code, whatever it may be doing, and then as it finishes, continue to proxy request to an upstream or your backend microservice that the proxy is protected. Why do I care about all of this? I got here and I was like, I don't know why I care.
A few questions like we're getting from the chat. So is WASM is replacement of AWS Lambda Azure functions? This is a very good question and very interesting question because it definitely might be. So depends where you're looking at.
Depends.
In the topic of this conversation that we're having right now, it is not, because it is more suitable for writing some of the internals things that just Danny pointed out with the proxy-wasm. But there are some projects that mean to use WASM as a runtime for your serverless functions. One of these example is Spin. It is a framework from, what's the company name? Fermion or something like that.
Fermion, yeah.
And so they actually build a lot of like a framework for writing serverless functions, and startup time is tremendous. Like it starts almost instantaneously. There's no warm up. There's no spending time on kind of like warming up VM or like bringing containers. So that's very cool. So the answer is it could be. So the WASM WebAssembly in general, it's very like very cool destination, and multiple things can be done. Some of the folks on the Docker side of things even mentioned that if the WASM was in the stage when it is today, we will not ever get the Docker as we have it today, because essentially they would use the WASM runtime to run everything. So you don't need to have a layer of operating system. You don't have a layer of all these libraries. It's just a one runtime that has statically compliant one binary that will execute in everything. You drop your WASM compiled binary, and you will be running.
I forgot where I read that. I forgot that point. That's a good fact.
I
love that. It's a fun fact.
Yeah, it was someone from the Docker team was tweeting about this. So another question coming here: why most use Envoy, what not Nginx on others? So okay, so this is a very interesting question. So when the Envoy come to be as a proxy server technology, they actually have multiple ways to extend Envoy. One of the ways to extend Envoy was Lua. There is still ability to write Envoy filters in Lua. Same thing as we do with Kong. Extend the Kong functionality in Lua. Here's the thing. Lua is the language, but in terms of Envoy and in terms of Kong, they are different. In the way how the Envoy deals with the things, in the way how the Kong deals with things is also different. You can think about this and how you can port the code, but if you want to support both things, you're writing plugin. You are the developer of the plugin, you vendor, you have, I don't know, you have a web application framework technology that needs to be run inside both Envoy and on proxy and Kong and Nginx. With proxy-wasm, it gives you this platform that everyone can program against, and it will, if this proxy-wasm platform supported in Envoy and supported in Kong as of today, um, those things would be portable to the point where it's kind of write once, run everywhere. Basically, I'm sorry for bringing this in. It's our Java thing. We would like to bring this in, like write once, write run everywhere. But it is how it works. An interesting thing. So we at Kong, we developed this. Let me show you this real quick. Kong, and I will switch to the screen just in a second.
So I think it's also worth mentioning that wasn't it the proxy-wasm first came out of out of Envoy first, and then
Yes.
adoption started progressing from there.
Yeah.
So
what
you'll hear
Envoy
about
did,
Envoy a lot for that reason.
Envoy, what they did, they found the ways that how we can write the filters. Lua, as I mentioned, C++, which is great if you know C++. I don't. And after that, they said, okay, so what if we will bring the WASM platform? So you will be able to run the WASM filters, and this is how this thing with the proxy WASM started. So they started providing these filters, and after that, again, okay, so let's find a way how we can have this like a framework that will be running on top of these things. So we at Quonk, we develop, and I believe it's open source right now. Yes, it's open source. It's freely available. It is a module for Nginx, and to explain this, we have slides from Danny.
Yes. So we have, as you showed, the Kong engineering team built the WasmX Nginx module. And so if we were to take a deep dive into what's going under the hood, I kind of abstracted away most of the Nginx stuff. So in purple here, we've got Nginx. This is Kong, right? As a whole, we've got Nginx. And what we're typically interacting with, what we're used to interacting with for our custom plugins and anything we do with Kong, like the admin API, is use OpenResty to interact with the Lua JVM. That's all in blue. So whenever we write a custom plugin, it actually happens to happen in this Lua JVM location, basically.
Logit, yeah.
Yeah. Now, when it comes to adopting proxy-wasm and having a sandbox running within Kong, what did it require? Well, the engineering team basically built the WasmX Nginx module that's open sourced, and within it, it will instantiate a WASM VM for you, where you can now write it's called a filter. It's essentially analogous to a plugin, but it's called a filter now. And this filter, so we've got these filters of.
It's just to be consistent with nomenclature that available around the world. So inside the proxy-wasm and the Envoy, it's called filters, and we don't want to have a confusion. We just like inherited this nomenclature. Nomenclature is how we say it.
Yeah.
Nomenclature.
And if we were to blow it up, so these filters, they look like they're outside, and this actually caused a little bit of confusion, but truthfully what happens is these filters are going to be deposited when we run them with Kong. It helps kind of shoot them in there, and so your filters are running inside this, like, if you imagine your VM blown up and all the processes running, these filters would be in there, running in the sandboxed runtime for you. And yeah, that's fundamentally how it's going to work. I think someone had a question about either or custom plugins or filters. So Vic pointed this out.
There's a question. Does this affect how custom plugins are compiled and deployed?
Do you want to go?
Or yeah, I mean, it doesn't. So it doesn't affect anything how the custom plugins work. So we still have custom plugins, same ways it's configured as you're doing today. You're defining the plugin. You put this plugin that it will be available to Kong to invoke. And if you're using this Lua, so it will be compiled in a runtime with just-in-time compiler with Lua JIT. and it will be executed as a machine code. WasM filters would be executed after conk plugins. So
After.
you can have multiple filters afterwards. So we have our conk plugins executed first, and after that, the request will be passed to the WasM filter chain.
Yeah. So if we're looking at this from a diagram perspective, all of the Lua plugins are executed first, and then you kind of start to hit your WASM plugins within that sandbox.
Very interesting question. What's the expected overhead of using WASM instead of writing Lua plugins? Um, I love this question about the premature optimizations. It's makes you sounds forward thinking. Let's put it this way. So it depends. I will answer this as a typical consultant. Everything is really depends what the plugin does. It really depends about um, what kind of stuff you're doing inside your filter inside your plugin. But in general, WebAssembly VM is super hyper performant, so we should not see order of magnitude difference. We can see, nanoseconds, milliseconds difference. Um, the core module, like core VM, runs inside the conk process. Everything happens within one process, so there's no overhead comparing to, for example, if you ever use the PDK for languages like Go, which would be running kind of like a sidecar and communicated through the socket. This is where you can see difference in terms of like order of magnitude. But with WASM, we don't have the anything in terms of like a performance the published yet, but there's some work happening, and we're happy to talk about this. If you have a particular use case, you have a particular filter, you have a particular thing to test it out, we here to help. Just like drop us a note, and we can work and play around with all this performance stuff. I love talk about performance and all those kind of things. Maybe next time, or I really want to show. Um, I want to bring the tracing into the bits. Today we're not gonna spend this time, but like tracing that is built inside the gateway is great tool to showing all the things, how all the things are piling up, and you will see that the plugins actually don't spend much of the time. Usually, much of the time we spend on communicating to upstream services. you know, uh, uh,
Claudio does
get,
a lot of that in his perf testing. He always makes sure to include certain plugins to understand what is the performance impact as he's like performance testing some type of alternative infrastructure.
right.
It's pretty interesting. Yeah.
And it's always about so we have a very interesting conversations with the people that concern about performance of the Lua, and Lua JIT is a performant virtual machine. WASM VM, so we're using we support Wasmer, we support WASM time, and we support VMs.
V8.
V8 is
We've got all
a
three.
build.
And the default, what's the default? I looked up
Default, I
default.
think we're using the WASM time.
Wasm time.
Yeah, WASM time. Um, and yeah, so the how it works, we actually have like different binaries or like different images compiled with different versions, but I think the WASM time is the one that we use by default because it has less friction for our like operations people who building our images and deploying these images into production, like Docker Hub and things like that. So now, why? Again, we still not answering the question like what's the fudge and why. Most importantly, the cool thing is that the proxy-wasm already includes some of the examples, some of the filters. Community developed the filters. We do see that it is much not easier, but at least we can integrate some of the existing things into Conk quicker. But for us in Conk, it's more important that we might have a feature parity between two platforms. As many of you know, we have a service mesh called Kuma, which is control plane for service mesh that uses Envoy as a data planes, as a sidecars to run together with your workloads. And in order to extend these functionalities, now we're killing two birds with one stone. We will be
Imagine the
able,
world.
yeah, in a world
Yeah.
where the Kong and the Envoy filters work seamlessly, and you can move things around. So you can develop one filter that would be scalable, rate limiting filter that works on Envoy,
It
and
will
it
be
will work.
beautiful.
It will be beautiful. Um, and there would be very interesting thing to very interesting thing to see. So the next thing is that, like, stop talking, let's see some code, let's see some stuff,
The
right?
code.
Get to the code, get to the chopper. Yes, so the once again the bunch of stuff we have here. So it is the module that you potentially can run even on Nginx. Potentially, I'm not telling you that this will work, but um, inside Nginx, that's what I'm trying to say. That's the module that you want to try, and it's already built in the Kong. And if you're using the Kong images starting from 3.4, it's already built in. There was a announcement, there's a blog post, there is a, more importantly, developer documentation, and more importantly, there is a example. So there's a project that we're gonna use right now. It's called proxy-wasm Go rate limiting. Um, and where is it? It's on my screen. Go rate limiting. Um, Let me bring this in. IntelliJ, where are you? So the way how it looks like, let me refresh it. My Go is not cooperating with me for some reason today. So essentially, there's a couple things that needs to be done. Let's take a look on the Go module. So we're using proxy-wasm Go SDK, which is a library that you will compile your code against. And this library provides the entry points to everything that you need to do with the everything you need to do with your application. We do have a it's relatively advanced use case. So, but it will give you idea about what this thing can do. I do have a like more simplified. Let me start with more simplified version, and after that I will go with the um, and I will go with this one. So, and in order for me to use more simplified version, I'm actually will be using examples from proxy-wasm Go SDK. So proxy-wasm Go SDK has examples, and one of the things that has HTTP headers, like simple enough. So what we do, we want to take the HTTP headers, add append HTTP headers, update HTTP header, um, or like change it or whatever. The way how it works, and um, where's the application starts? Application starts with setting the VM context, and VM context will include all methods that we need to re-implement. So the proxy WasmX would know what to invoke. Um, in their documentation, they actually have a very interesting ASCII art diagram that explains how the things work in terms of like what you need to implement and what you need to go through. So VM context will include the configuration for your VMs. You can choose these to interact with your VM configure things. You can instantiate the plugin out of VM context, and it can be multiple plugins within one VM. And after that, you can have multiple HTTP contexts per plugin. In our particular case, what we're interested in a couple things. When the plugin starts, proxy-wasm provides some of the helper functions in order to get the configuration. Say you need to configure this, providing some external configuration. That's important. That's the important thing to have inside the um,
So plugin start
inside
instantiates the plugin context.
exactly.
Good.
So in this particular case, what they do inside the configuration, they just need to get the header name and header value that we will be injecting in our workload, in our request. Sorry. Um, And when we have this method called on request headers, meaning that the proxy will invoke this code for you and will pass whatever information you need. In this particular case, it will bring you here. Like you will be able to interact with the context that will be populated with the um, important information that you require in order to do something with this. In this particular case, we can get the request headers because we on the method request headers. Getting this request headers, and we can do whatever. So we want to append our headers to response headers. So in this case, we need to invoke on response headers, and the proxy-wasm provides functions in order to invoke, to add, or in this particular case, we can add. There's also something like there's also ability to append. You can add to existing headers if their header exists. Just need to change it and things like that. So and the as a result, you will get very interesting things with your application. Now, that's the simple thing. So let's show the example that we have. Rate limiting. And the rate limiting is actually implementation of rate limiting some algorithms. If you want to check this out, you can go and check this out. And plugin starts, reading configuration, plugin starts, HTTP context. I'm looking where's there we serving requests. Let me see the command 7. Where's the HTTP plugin context, VM context, rate limiting? Where's it? Yep. We also modify HTTP headers because we want to include rate limiting headers into HTTP response. What this is a response header. So we replace response headers. We take the no, where is it? We put the headers what we want to modify. In this particular case, we're gonna put the X rate limiting whatever, and we will be able to do this. Now, I really want to go and run this thing. So let's take a look. So the way how it runs is, again, this is this example that's available. That's project already there, so you can play around today. Now, there is the shell script that show you how you can build this. But before this, we need to talk about one small thing that is very important. And this small thing is called TinyGo.
Oh, it is small.
TinyGo.
It's tiny.
Let me check if we have any comments so far. Okay, so we go. So, is it possible to use dispatch HTTP call? So, if we will have a time, we can just try to copy example what is available in proxy-wasm and see how it works. Otherwise, we'll see. We're not gonna do this just like one time. Like it's gonna be a longer running stream. We're gonna talk about this a lot. Now, so what's the TinyGo? TinyGo, it is a kind of like the smaller version of the Go runtime. Essentially, it's a compiler that designed to be executed and create the binaries for embedded systems. And WebAssembly community find a way how they can use the same thing to. Yes, Danny, please.
Fun fact. Actually, if you go to the TinyGo homepage, it says now officially that it's meant for embedded systems or WebAssembly.
Nice. Yeah. So the people use this, I guess, use this a lot. And one of the targets that they have, it's called like WASI. It's called WebAssembly System Interface, meaning that the binary format will not be in a format of ELF for Linux or Darwin for for macOS, and I forgot what's the format they use for Windows. It's special type of bytecode. Why is that? The WebAssembly doesn't have garbage collector. So that's why all the things that will be running there needs to be statically compiled. All things, all packages inside the Go, if they work with reflection or any type of kind of like a runtime type tinkering and like doing the stuff, they will not work. They will not compile. So you need to find a library that will be either specifically will say that it will not using reflection and it has like just the things on the core Go, or they will specifically point out that this library um, designed to be run inside TinyGo. So let's build this. Let's build this. Let's build this. So we're going in to build rate limiting WASM.
So you build out the filter in TinyGo using the proxy-wasm SDK, step
Yeah.
one, and then you gotta build out the WASM module.
Yeah. So I'll start with
Okay.
cleaning this stuff. I removed this module. So let's start building this module. So it will execute TinyGo compiler. So this toolchain needs to be installed in your computer or in your CI. If you're running this on CI, this example also includes how you can install this toolchain on your CI. So it uses Go 119. It should work 120 as well. TinyGo 2.028. It works also with 229. I tested this. Okay, now we compile this. And what we see here, this is the file. We can see LL inside inside the test directory. Inside, oops. Okay, LL test wasm. So it is 1 megabyte of file. So this is your filter. This is your filter that we're gonna be configuring this. How this will work with Quang? Couple things it needs to happen. So first thing is that let's start with configuring Quang itself. So
Okay, we're
we're
on
using
step two. Step two,
yeah
right?
yeah.
Configure
So
Kong. Okay.
and I will put this into my markers. Configure for WASM. I'm making the markers so I can when export this into YouTube, you will have all the time codes. Now we're running the con container, and the con container requires a few things to be configured. One thing is that we need to enable the WASM. By default is disabled. So question to overhead. It doesn't have an overhead if you're not using any filters. VM will not be instantiated. It will not start it. It will go as is. So next thing is that we need to show location where all the filters would be placed. In this particular case, we take in this directory from our script and mounting this inside our container inside the WASM folder, and we specify the filters will be here. And that is pretty much it. We can configure some of the configurations. So in this case, SHM, it's the some sort of kind of like a small database embedded in memory database that allows us to use is this for storage. Specifically, we use this to store the counters for rate limiting by key. Um, Again, this is used by just for example purposes. For more production versions, probably will require some of the interactions with the I don't know like Redis thing that we showed in the
Redis.
previous examples.
Usually Redis, yeah. But moral of the story
Yes.
is analogous to, I guess, if anyone's familiar with custom plugin development, we have to basically have the Lua rocks file installed on the gateway image. Similarly, even though we're in the WASM ecosystem, we now need to compile the module and have the module inside or mounted to the gateway container.
Mm-hmm.
Same
So
thing, same situation.
I want to address one of the comments that we have from the LinkedIn. Danilo asking, is there an example in Python? Okay, so there's a short answer and there's a long answer. Which one you want? Let's start with short. No. And long answer is I will explain why. So we program this in the WASM against the proxy-wasm SDK. So where is it? Proxy-wasm SDK. And proxy-wasm SDK, if we go into proxy-wasm specification, this is a proxy-wasm GitHub organization, and it says WebAssembly for proxies. Officially, there's only 4 SDKs exist with different level of kind of like a quality. I couldn't, for example, I want to try kind of like a TypeScript, JavaScript type of development with the WebAssembly inside proxy-wasm. Didn't work out for me. Maybe I should try better. C++ SDK. You can write the C++ modules, but why would you?
Why would you want to do that?
I mean, probably because of the some certain limitations that we have in the TinyGo world. For example, not all libraries are supported and things like that.
Yeah.
Rust. This is where, like, if we would announce that we're gonna be doing stream with Rust, like, we'll have a much better attendance, because this is the kind of like a language that gives you internet points. Uh, but thing is, um, the Rust, when it was created, WebAssembly was one of the things that, as a like a standard targets for WebAssembly. The Rust has the best support, and some of the libraries works great with this. Write down in the comments if you like to see us doing some Rust stuff. Um, this is information is outdated. It requires PR. That will include Quonk now. So, short answer to Danilo: no, there's no the Python SDK for proxy-wasm. If someone will develop a proxy-wasm SDK for the Python, it will work without problems with Kong, because language, it would be agnostic to the thing. You will be able to compile this library into WebAssembly, and even this, you don't even have to compile this. You just give me this binary. I can give you this binary, and you will be able to execute this. Even though I'm on Mac, you on Linux, you on Windows, it's a
It'll work.
platform independent binary. I can share this through the GitHub, even though I feel dirty every time I'm sharing binary through the version control system, but it will work. So I hope I answered this question. Now, okay, so the moment of truth. We ready
Right.
to run this?
Mount getting it on the container. Yeah, getting it on the gateway container.
Yeah, so we run this inside the gateway container. So let's see, where is it? We are in the test folder. We're going into test folder, and we run this demo stage. So what it will do? Oh, okay. I didn't mention one thing. So as example, we're running this in the DB-less mode, meaning that there's no admin API available, but we want to use declarative configuration. And many of you knows that we have a services, we have a routes, we have a plugins on the route, but now we also have a filter chain. And this is where we need to specify filters. In this case, rate limiting is the name of our filter without WASM extension. So if you have a, I don't know, hello-world, so it will have here another filter called hello-world. And this configuration, we can provide like a 3 requests per minute. That's what we're getting. Let's see. Ooh, I love this. Something is not working. That's the
That was
motto of Kong builders. Let's take a look. If we're gonna do requests, will it work? So let me restart the container real quick. Yesterday it worked with containers. Delete forever. And when I restart this, let's see demo. So we configured one of the routes that will be pointing to mockbin. Let's see why it's not doing whatever it's doing. So I'm looking inside this container, and let's take a look. So we see that the WASM. Can I make this bigger? Oh yeah, I can.
yeah, it's
So
tiny.
we can start this. The WASM thing is actually working, and we see that rate limiting plugin was instantiated.
Oh,
WASM
you can
time.
see the
I need to
runtime.
check like 1, 2, 3, 4, 5. I believe it's just like it runs this in each Nginx worker that will run
In
the
each
conk.
thread. Yeah, each worker thread. That's
Kind
what I
of
was
like
kind
a
of
like
wondering
working
too.
thread, yeah. So
Yeah.
we start per 1, 2, 3, 4, 5. So it's multiple requests will be spread across these worker nodes, and each of them will be, have its own instance of this um, declarative configuration loaded. So my port 8080 should be up, right? So what is not working? So let's do this one more time. Let's do echo. Okay, 2, 3. Okay, perfect. So it just
Hmm.
like it was a data race that
Just,
happened. So
mm-hmm.
we configure our rate limiting to hit 3 requests per minute, and now we actually get the response. This is the rate limiting that came from Go informs. Go informs. Um, let's
And the
do
headers are
something.
there too.
Let's do something cool. So let's see if we can break this. Where's the main Go? We go into where are we adding the headers? Um, HTTP context. Um, 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 um. Let me see. It's just like navigation is. I'm terrible. Like on response headers. So we put the replace HTTP header response. Also, we can do proxy-wasm, add HTTP response header, add x conk builders. Yeah. So
Ayo.
let's see if this will work. So we need to compile this, make rate limiting. I think I need to do this in a different directory. Here, oh, nope, sorry. Rate, rate limiting. I will compile this. We'll compile this. I will stop the container, delete the container, delete forever. And now when I go back to test, I will be able to run this demo. Next time, I will show you the better way how we can test this, hopefully.
Oh
Uh,
yeah, it's gonna be super cool.
hey,
Hey.
so that's the gist of the thing. So um, there is a binary available for you to play around. So images, Docker um, Docker images for Kong that includes this WebAssembly runtime is already there. We do have a few examples for you. As a matter of fact, like if you don't want to hang around in suspense, we actually have a template for you to start. You can just like mm, I was wondering why this project not GitHub template. We can do GitHub template and start new project from template. I'll fix that later. But for now, you just like fork it and call it whatever you want. It has everything that you need to have. So in this particular case, it has even example of proxy-wasm that includes where is it? Yeah, does like X greeting thing here, which is pretty dope. Also, if you go into Quonk and you do say Rust, you can find there's a proxy-wasm rate limiting template in Rust. That's kind of something that you can explore in your own time, or next time we can talk about Rust. But essentially, it's the same idea, but in this case, it's implemented rate limiting using Rust language, implemented using the WebAssembly, and this also will be executed. Another thing to explore. I was showing this to Danny before our stream. This library, the proxy-wasm Go SDK, actually very good example, has a very good example of the things that is available. Um, where's our Mateusz was asking about dispatch HTTP call. So I'll try to look to this one offline, so I will not spend the time and looking what's the problem. So looks like he has some problem using dispatch HTTP call. That definitely is something that needs to be brought up to the team so they can take a look and see what kind of problems are there. Um, so very good question. Danny, you want to take this one?
Ooh, yeah, use cases. I did actually ask around this exact
Oh,
question, and one idea that came up was that with the SDKs, because you're just more familiar with the language, and you may have an easier time if you need to integrate with external systems of some kind in that, in line with the any activities that you do in the proxy, right? If maybe you needed to call out to, I don't know, a database or grab some extra data to append to the header before it's proxied to the upstream, some process like that, that would be a good use case for using the filters versus Lua, just because you may have an easier time coding it out.
so question is here. I'm wondering how you debug this. Actually, it's not that bad in terms of debugging. If you look inside, if you look inside, um, where is it?
It's a
My
great
screen.
question.
Yes. How you debug this? If you look inside examples folder for proxy-wasm SDK, all these things actually come in with the tests. They have the basic testing functionality. So there's a proxy test available. So you will be able to have like a proxy context for your filters. This is how you would do your program against SDK. So you need to use the tools. Another use case that I personally use and like to use for my Kong integration testing is the test containers. Hey, okay, I spent like a 55 minutes holding myself, not talking about test containers, but here we go. I actually wrote the module about the Kong and the Go and test containers. Um, if this video will take, I don't know, let's do like 20 likes, whatever. Like if this video will have 5 likes, I will do the stream about the test containers and Kong and how you can debug these things.
We
It is
have to do
actually
test
pretty,
containers. It's so cool.
yeah. So you will be able to debug this if you're developing this, you using tools that the proxy WasmX SDK provides to you. If you need to debug this in integration with Kong, um, I will go and show you how we can do this with test containers. Uh, all right. So, Mateusz, we can definitely speak offline about this. I'm curious about this use case. I know there's some, this thing is new. It's not GA. It's a thing that we working like very hard for the last, I don't know, like 2 years or whatnot. Last year at in the Kong Summit, and we announced some of the like a technical preview, and the technical preview was like 100% different from what we have right now. In the past, it was kind of like a low wrapper that will be calling this underlying plugin. Now it's kind of like a parity in terms of like they have its own configuration thing. There's like a best bright minds working on this from the Kong side of things. So bear with us. There would be some of the rough edges, and that's why we're here. It's the builders. It's not like, oh, dear Mr. Customer using this. Customers don't care about this. Developers, you are developers and you care about this. Hey, actually, submit this as a hackathon idea. To build a
It's a good idea.
filter with the proxy-wasm that will, I don't know, using ChatGPT to do something. I don't know. Like ChatGPT does like maybe okay. So next time we will
It's an
check if the
idea.
ChatGPT knows something about the proxy-wasm and can contribute some of the examples here.
It's also an idea.
That's a cool idea. All right. Why it is here? Okay. This is the reminder. Where is it? This is the reminder that my name is Viktor Gamov. I am a developer advocate here with Kong. this. It's the Danny Freese from Partner Engineering. And we're excited about those features. We're excited about the con builders, and we're excited about showing you what's new and exciting comes into Kong. Hopefully, you will be able to play around with this and let us know. Write down in comments, like in the comments below, what's the next thing you want to see. I definitely want to spend some time um, um, building the compelling case with the containers and test containers. Where can we get this Kong t-shirt? So the only way how we can get this awesome Kong shirt is only come and work for Kong and build some awesome Kong stuff. It comes with job description. So check our website. There's some different opportunities for joining the team. Please, by all means, uh, we're happy to we're happy to new Kongers. With this, do we have anything else to add, Danny? Do you have anything else to add?
Don't forget Summit next week.
Yes.
Deep sigh.
API Summit. Go sign up. The hackathon. Go sign up. Um, um, Huge thanks to Danny for awesome diagramming. We're gonna share all these things somewhere. Probably, I will use this in my test containers repository documentation.
It's a good
Here we
idea.
go. We will put this there. And as always, my name is Viktor Gamov, and as always, have a nice day. We go in with outro in 3, 2, 1. See you next week at the API Summit, and we'll see you next month at the Kong Builders.